Hey everybody, Ms. Dietrich here. Today we're going to talk about how to use unit rates, which is lesson 4.7 from the Go Math. Let's take a look at this first example. It says the Champies are traveling from Arizona to Texas. On the first leg of the trip, they drove 500 miles in 10 hours. If they continue driving at the same rate, how many hours will it take them to drive 750 miles? So we have a couple ways we can do this. We've been talking a lot in class about the idea of proportional reasoning and setting up your proportion. Look to see what the units are that they're talking about. They're talking about miles, so I'm going to put an M over here, and they're talking about hours. And if we turn this into a rate, it's 500 miles for 10 hours. All right, now the first thing we should do is we should explore whether or not this ratio can be simplified to a unit rate, and it can. And how would we do that? Divide both of these by 10. So if we do this divided by 10, we get 1. And if we do this divided by 10, we get 50. So as a unit rate, it's a 50 to 1 ratio. Then we have to decide where to put this 750 miles, because it either has to go on the top or it has to go on the bottom. The answer to the question, where does it go, is you pay attention to the units. Since it's talking about miles, and we have miles written as the numerator, we would want to put that as the numerator. And we're solving for how many hours? All right, now, as it turns out, 50 is compatible with 750. 50 times some number does equal this. So we can take that same number and multiply it by 1 to get the number of hours. So let's divide that out to find out what it is. All right, so 50 won't go into 7, but it will go into 75 once. And if we subtract, here we get the 5, bring this down, get the 2, bring this down. All right, and then if we do times 5, let's try that over here. 50 times 5 does equal 250. All right, so that worked out evenly. And we got 15. All right, so that magic number then is 15. So that means if we do 1 times 15, we'll get the answer, which would be 15 hours. All right, so a couple of things I want to point out. We got 15 hours. If we were to go back to everything I had originally written here, so let's move all this stuff out of the way. And let's move this out of the way just to go back to what we had. So we're saying that H is equal to 15 hours. You don't have to sit around and wonder, did I get it right? Because you can check your cross products. Did you know that when you multiply this times this, you should get the same thing as if you do this times this? Now, 1 times 750 would be 750, right? So we just have to make the cross product here would be 7,500. If we did this right, then that means that these two numbers multiplied together would be 7,500. If you check with a calculator or do paper pencil, you'll find out that the cross products match. All right, let's take a look at another example. So I think I want to look at it using proportions, and then we'll go back and look at another way that we can solve it by using what some people call a bar model or a double tape diagram. All right, but let's try proportional reasoning first on this question, which means equal sign and 2 fraction bars. All right, so Kenyon earns $105 for mowing 3 yards. How much would Kenyon earn for mowing 10 yards? So first we need to figure out what our units are. What are we comparing? We're comparing dollars to yards. Dollars and yards. So it's $105, 3 yards. All right, now we might explore whether or not we can simplify that. Now another thing I should mention, if we substitute this in where it goes, so the 10 would go here because we're talking about yards. If you're lucky enough to have these two numbers be compatible, then you might not need to reduce this ratio on the left. You could just leave it. But since 3 is not compatible with 10, that's when you want to go ahead and look to see if this can be simplified. And it can be. Both of these are divisible by 3. The divisibility rule for, can you tell if a number is divisible by 3? If the sum of the digits is divisible by 3, then the number itself is divisible by 3. If we add this up, we get 6. Since 3 goes into 6, we know 3 goes into 105. So we know 3 is going to go into that one time, but we need to figure out how many times it'll go into 105. So I'm just going to use the calculators to speed things up. So if we do 105 and divide that by 3, we end up getting the 35. All right, now you can easily see that we have the shortcut going across. Since 1 times 10 would be 10, we can take the 35 and divide it by 10 and get our answer, which hopefully you can see would be $350. All right, so let's go back and look at the same problem using a tape diagram. So same exact problem. So if we draw our $105 and our 3 yards, see yard number 1, yard number 2, yard number 3, we already know, because we figured it out in the, here, we know that 1 yard would be $35. So let's put that number right here. So if that's 35, this is 35, this would be 35, which means that all of these would each be 35, right? Because they're talking about 10 yards. If we count these boxes, there are 10 boxes here. So if each one is 35, and we need to figure out how much money for each, we would just do 35 times 10 and get the 350 that way. That same strategy would work. So this, they call this a bar model. All right, so let's look at another example. Let me find one that I like. Let's look at this one. Last summer, Kenyon earned $210 for mowing 7 yards. How much did he earn for mowing 5 yards last summer? So this one works very nicely with proportional reasoning because the numbers are reducible. So once again, we're talking about money and we're talking about yards. So it's $210 for 7 yards. And we want to know for 5 yards. So we have to decide where to put the 5. Since it's not talking about dollars, it's talking about yards, we'll put it on the bottom. Now, if these numbers had been compatible, like if this had been like a 10 or a 15 or something that was a multiple of 5, then it wouldn't be necessary to reduce this. But since it's not compatible, then let's look at seeing if we can get this to be a unit rate. As it turns out, both of these numbers are divisible by 7. So if we divide that by 7, we get this. And if we divide this by 7, we get 30. So it's a 30-to-1 ratio. If we take advantage of that number, 1 times 5 would give us this 5, so we just have to multiply this by 5 to get the number of dollars. That's easy enough. That's mental math. That would end up being $150 for our final answer. All right, now again, if we go back and look at the same idea using a tape diagram, then we would draw out our 7 yards, and then we would still come up with the idea that each one of these is 30, 30, 30. We could write the 30 all the way across. So then we would do the same thing for if we're doing 5 yards, 30, 30, 30, 30, or 30 times 5 would also give us the same answer of $150, right? All right, so let's move on and look at some other examples. Let's look at a simple example like this one. So if we have to solve for the box, first, these numbers are not compatible. Next, explore whether you can simplify this. So both of these numbers are divisible by 6. So if we divide this by 6, we get 1. If we divide this by 6, we get 5. So if we clean this up a little bit, I'm just going to rewrite it down here nice and neat. 1 to 5, 14 to some number. Since 1 times 14 would equal 14, we could take advantage of that by multiplying 5 times 14 to get this value. So if we just quickly do the 14 times 5 off to the side here, here we get the 20, here we get the 5, and the 2 more makes that 70. So the answer is 70. N is equal to 70. Now I want to point out a few things, and that's the idea of cross products. So whether we take the simplified version of it or not, so let's, in fact, let me move this out of the way to show you what I mean. So we're saying that N is equal to 70. Now, if we check our cross products should be equal, otherwise there's a mistake. So if we look at this cross product, 1 times 70, we know that's 70. And if we did 5 times 14, that's also going to be equal to 70. But what if we look at the cross products of the unreduced version of this thing? So let's erase all this so we're not distracted. And let's look at the cross products. So if we do this times this, that would equal 420. Well, guess what? If we do this times this, that's also equal to 420. So how might we use this on a multiple choice test if we're all mixed up about proportions? We might look at the answer choices, substitute it in to the unknown to see which one results in matching cross products. All right, let's look at something where I think I want to look at one where these are not compatible and this can't be reduced, because when you have both of those true, so again, let me say that again. These are not compatible. 14 is not a multiple of 8, and this cannot be simplified. Then you have to use cross products. So let's look at what that looks like. So I'm just going to put an N here. Now we know that one of the cross products would be this, right? 14 times 9. Let's put that over here. And the other cross product would be going this way. By the way, they have names for this stuff. They call it product of the means and product of the extremes. So this is 8 being multiplied with n. So I'm just going to write that over here. All right, so in the interest of saving time, let's use the calculator to find what 14 times 9 is. And we get 126. So what does that mean? If this is equal to 126, that means that these two numbers multiplied together also have to equal 126. So let's go back to what we studied when we did our algebra unit, which is how do you solve this equation? Well, you find the coefficient. Here it is, right? 8 is being multiplied with n. What's the opposite of multiplying a variable by 8? Well, it's to divide by 8. The 8s would cancel out or equal 1. 1 times n is n. So we just have to find what 126 divided by 8 is. In the interest of saving time, let's use the calculator. 126 divided by 8. And we get 15.75 or 15 and 75 hundredths. Or if you prefer, 15 and 3/4. That would be equal. Now guess what? If we put this number in the place of n, or its mixed number equivalent, which would be this, and we multiplied that by 8, did you know that we would get 126, right? Because if we didn't get 126, then we would have to check to make sure we didn't make a mistake. All right, so now let's look at another example where things get a little more difficult when we start to get into decimals. So same kind of idea. These numbers are not compatible, and this is not easily simplified in our head. So then we would want to use cross products. So we have this cross product, 3 being multiplied with 1 and 25 hundredths. And we have the other cross product, 2 being multiplied with n. So let's find what this equals. We'll use the calculator. 1 and 25 hundredths times 3 equals 3.75. 3 and 75 hundredths equals 2n. All right, so we just did this times this, and we got 3.75. Well, that means that the red cross product would also have to equal 3.75, right? Because they're equal. The proportions are equal, the cross products have to be equal. So how do we solve that using algebra? What's the opposite of multiply by 2? It's to divide by 2. So once again, we'll take our calculator. We have this number here, 3 and 75 hundredths, and we're going to divide that by 2. And we get this number, 1.875, 1 and 875 thousandths equals n, because remember that cancels out. Now guess what? If we were to take this number and put it in the place of n, so I'm just going to write it in a different color, 1.875, and multiply that number by 2, we should get this number, right? Because equal ratios have equal cross products. Super important that you understand that. All right, so there's another problem that I'm going to make another video, but this question right here, it's really best to do a tape diagram for this question. So I'd like you to just look at it and see if you can figure out how to approach this, and look for another video on how to do this exact question. So you'll just put it on pause, read it, and see if you know how to figure this one out, and then look for the second video. All right, very good. Hopefully you found this helpful.